Okay. Good morning, everyone. So today we are starting a new topic which is related to GIS data collection, where we will be studying that how different primary data as far as secondary data we capture and collect in terms of with reference to specifically GIS data collection. So let's start with these two data types, the primary data collection. So what kind of primary data collection we go with reference to the specifically GIS data sets that we are going to study, and what are those datas, and what are the different agencies, and what are the different data types that we are going to study in this today's lecture. So primary data collection, data that is created in-house, that is known as primary data. Like what we are creating by our own, that is the primary data. The most expensive part of GIS, most estimates say that the 80% of total cost is for the primary data collection. So primary data is the most expensive part of GIS data collection. Then we have manual and vector input. When we are talking about the primary data collection, so first we have the manual vector input, where we have digitizing tablets, where we have on-screen digitizing text files and COBOL. So these are the four major types of the manual vector input data in terms of GIS, which is a part of your primary data collection in GIS. So in manual or vector input, we have digitizing tablets through which we are going to connect on-screen digitizing text files and powers. So let's discuss one by one these manual vector inputs, in which the first is the digitizing tablet. Now, this digitizing tablet, it sends an electrical impulse from the edges, okay, from the edges, that is read by the puck, okay, to determine the location. The accuracy of these tablets ranges from 0.01 to 0.002 inches. Okay, so this is the digitizers. Okay, now it records and indicate the movement of the digitizing tablets as a pair of X and Y. Okay, and then this is a photographs where we are trying to tell about the digitizing table, the park, and with the help of which we collect the various points in terms of the pair of X and Y locations. The accuracy of these digitizing tablets, it ranges from the point 0.01 inch to 0.002 inch. Then the second is the procedure of these digitizing what is the procedure behind the digitizing while we are digitizing through these digitizing tables. The turn on digitizer and a place on map tablet, this requires let the map and tablet reach the thermal equilibrium, tape the map to the tablet, register the map using control points. At least 4 points you have to have on the location which is known to us. Then digitize the feature, fix the digitizer error, which is also known as the topology. Okay, so while we are digitizing, we need to follow this procedure where firstly we need to turn on the digitizer and place the map on the tablet. Okay, here you have to place the map on this tablet. Then the second step, tape the map. We have to tape the map from these four corners, and then register the map using control points, where you need to go for at least 4 points, known points of the map, which you also take while you are georeferencing the maps. Then digitize the feature, and fix the errors with the help of topology. Then two methods of digitizing are there. One is the point mode, the second is the stream mode. Okay, whenever we are going to go for the digitizing, as you know, we have three major things: point, line, and polygon. Point is a single point where we capture the x and y with the help of puck button, and that is called as point mode. Okay, this gives you more accurate data and it requires less skills, whereas the streaming mode, here we can go for the digitizer will send the location while puck button held the down. It requires more skill and it can be faster, but the slow operators will capture many points that less than necessary. Okay, so there are two modes. One is point mode where we go for one location captured for each click of the button which you presses on the puck button. Okay, this technique is more accurate and it requires less skills, because every click whatever you are doing on that is getting captured. But in case of stream mode, the digitizer will send locations while the puck button is held down. Okay, it will send multiple locations when you click the button. Okay, it requires more skill because it is sending many points on a click of once, and it can be give you yes, it may give you faster results, but the operators may slow capture the points, or maybe excessively captures the point of the necessary. Okay, so this is the about the two methods of digitizing while we are going for the digitizing purpose. Okay, the point mode and stream mode. Point mode is easier. It requires less skill. It requires one go in a clicking of one button. Only one point can be stored. But in case of stream mode, when we are clicking one point, it may store many points in single go, which is faster in digitizing, but it requires more skill, because you have to be sure that this complete line or these 10 points can be stored in one go. Okay, so maybe at times you are also able to get or store many unnecessary points also. Okay, so two methods, one is point, one is stream. Then we have the second one, that is on screen digitizing. First, the digitizing tablet, on screen tablet digitizing, that is the second method. In case of on screen digitizing, we have the original is scanned and geo-referenced. Okay, the original file is scanned and then geo-referenced. The features are captured using the mouse, like the digitizing which we are doing by seeing the screen with the help of our mouse, that is called as on screen digitizing. It is less tidy than the tablet digitizing, which is also known as the manual digitizing. Okay, so this is less tidy, easy to capture, and the original file is first get scanned and then we go for the digitizing. Then repetitive motion injuries. Manual digitizing can cause repetitive motion injuries. Work in a location that minimize the stress on the wrists and the shoulders. Take a break. Use splint or knee wristband. Seek medical opinions at the first signs of the problem. Names of the people do manual digitizing. digital slaves, prisoners, grad students, automated digitizing. Now, firstly, we have discussed about uh, the repetitive motions of entries, which is due to the manual digitizing, and then we have also tried to see what is the after effects the automated or on screen digitizing. ठीक है. Now in case of automated digitizing or on screen digitizing, we have tools to automatically convert to raster scan to vector scan lines. Okay, then it requires a very clean scanning. Scan can be cleaned using raster cleanup tools. Vector files usually require cleanup after the conversion, and if you start with a clean image, it can save a lot of time. If your image is not clean, manual digitizing may be faster. Okay, so in case of automatic digitizing, the tool is automatically converting the raster to vector lines, and then it requires very clean scanning. Okay, you can go for the vectorization only if the scanning part is done correctively. Okay, then the scans can be easily clean up, and it can be go for the easily converting of one data set to another data sets. Okay, then automated tools are grid lines and arc scan extensions. Now, grid lines include the command lines or arc info command. It need a perfect image, and it can a large amount of cleanup after conversion. Okay, so when we go for automated tools, in case of the automated digitizing, the grid lines, they need following things, or they perform following things. The command line info command need a perfect image, and it can have a large amount of cleanup after the conversion. Then ArcScan extension, new extension at 8.3, and has a cleanup tool and first tool for ArcGIS that work well. Okay, so these are some guidelines about the software through which we are performing these kind of exercises. Now, ArcScan, how we go for the arc scan option. This is being shown by this tool, where we can go for different kinds of settings. Raster, you can select your image, then the vectorize setting you can go for. Cell selection also we can plan, and then different setups can be performed as per the requirement of yours. Then arc scan demo, what we can do with the arc scan, a demo can be seen. Then the text files. Okay, text file, in case of text files, if you have text file or table with xy values, we can directly import it into the ArcGIS in terms of the Excel or Access. Okay, or the database db files, you can call them the db files, or through Excel or Access. Okay, Microsoft Access or Microsoft Excel can be used to drag those files directly into the ArcGIS format if they have the XY latitudinal and longitudinal values. And GPS data also can be imported to the ArcGIS software, and then we can go for different kind of interpolation of things, where we can get the the text files converted into the maps. So here, in case of text file, we are exporting these text files to ArcGIS platform, and then we are converting or attaching these files with various xy values of these points, and then we are converting into the map platform. Then the COGO and survey analyst. In case of COGO coordinate geometry, the extension for command line arc info can be done. Then survey analyst, this is again an extension in your ArcGIS. through which we can go for the importing of these data sets. Then both extension can allow the direct inputs of your survey data sets. So we have discussed here about the manual primary data set, where we have the manual entries of vector inputs, where we have four different things which we can through which we can go for the manual vector input. One is your digitizing tablet, where we use the digitizing tablets and the puckers to collect the info. The second one is the on-screen digitizing, or the digitizing we use through the we do this is that is an on-screen digitizing. Okay, then the text file can also be imported into through Microsoft Access, or through Microsoft this thing Excel or DB files, and then GPI's data can also be explored. Then COGO and survey data sets can also be imported through the ARC survey analyst or the COGO coordinate geometry. Okay, so these are the four types through which we can go for the vector data input in primary data. Then we have lots many types of secondary data sets in GIS, and these secondary data sets, they have a large amount of data nowadays available. Okay, we can also check for the existing data before creation. Okay, before creation of any GIS, we can also see that what are the different secondary data available with different departments, and then we can create several groups of these data sets, where we can go for the free data collection from the government offices, government data available of fee, internet map servers, commercial data, and data from the other GIS users. Okay, we can categorize those data sets based on their availability, whether what are the types of data which are freely available with the various government organizations, what are the data sets which we need to go and purchase, or we need to pay some fee. Then what are the secondary data which are already available on different servers through internet, which we can collect. Then we can also plan for the secondary data which has its own commercial values, and then we can also get data from various GIS users. Okay, so we have large amounts of data sets, because so we can also go for the checking of the existing data sets, and we can go for the creation of these data sets in different groups. Okay, what are the different groups which we can get from the internet, which we can get from the different departments, government or non-government, freely available, or we can have to pay some fee. Then free government data, like we have various sites from which we can opt for different data sets, like USGS. From USGS we can get different kinds of satellite data, excuse me, thank you, freely available. Then the census data of India, that also we can get up to 2011. Then the NOAA data is also freely available. So there are large amounts of data sets which we can get freely available on different sites. Now USGS data, these are the different types of data sets of USGS which we can get freely available on different data sets. So DEM, digital elevation models, NED, national elevation data sets, NHD, national hydrology hydrography data sets, DRG, digital raster graphic, DLG, digital line graph, DOQQ, digital ortho quarter quad, GNIS, geographic National, Geographic Names Information System, then LULC, Land Use Land Cover, NLCD, National Land Cover Data. Okay, so these are different data sets which you can get from USGS data. Other than this, Bhuvan, from Bhuvan, you can also get various data sets, various layers of LULC at list 3 level. You can easily get from Bhuvan also. Then, now what are these different data sets and what kind of information we can get, or for which we can use these different data sets, which I have told you right now. Now let's start with the DEM, which is Digital Elevation Model. Now it is available in the several resolution. One is 3 arc second, where you can get 1 is to 2,50,000 intended scale and approximately 90 meter spatial resolution. Then 2 arc second, that is 35% of US coverage complete, 100% of New Mexico, at the scale of 1 is to 110 lakh. Okay, intended scale approximately the spatial resolution of this is 60 meter. Okay, then 30-meter dam also can be get at the scale of 1 is to 24,000 intended scale, and production stopped in favor of 10-meter dams. Then 10-meter dam, 1 is to 24,000 intended scale, complete for New Mexico, you can get easily available. Then 1 upon 9 arc second, approximately 3-meter resolution derived from LIDAR, very limited coverage at present. So these are the different spatial resolution data sets of different areas you can get easily available through USGS. Okay, now problem with these dams, there are some problems which are associated with this USGS dams, which we need to take care while we are downloading these data sets for different uses. One is created by contractors with different standards. Now these USGS digital elevation models, uh, they are created for different areas with different agencies or different contractors with different standards. So there may be a problem of data sets of matching. Then map projection units can vary, and then like for in maybe they have used some kind of regional projection systems, where they have used different, maybe somebody has used conical, somebody has used cylindrical. So there may be change in the projection, and units can vary. Okay, and can have gaps between adjustments and dams. Okay, for example, fix by filling for from a lower resolution dam, fix by averaging adjacent cells, or fix by NED. Okay, clear? National elevation data sets, maybe different national elevation data can be fed on these things. That gap can be seen, or maybe they can fix up by the neighbor cell values, or maybe they can filling with the lower resolution dams. If there are gaps in the adjacent data sets, so they can be fixed up by these things maybe, and there may be chances of error, these kind of problems, where which are associated either by the different standards, due to the creation of these data sets was done by different creators, and maybe the projections and units of represents are different, and there are gaps maybe between of adjacent data sets or adjacent DEM. So these gaps can be filled with either the filling up the lower resolution digital elevation matters, or maybe these gaps may be filled. So that's why there are some gaps, or maybe NED, national elevation datas. Then national elevation datas. What are these? They are created from the 30-meter or 10-meter digital elevation models generally. No gaps or units are standardized in case of NED datasets. 100% coverage of US data is being done. Okay, so these are the specialties of NED, National Elevation Datasets. Now NHD, National Hydrography Datasets. Now it can be get from NHD data can be explored through this site http colon slash slash nhd.usgs.gov. Okay, so National Hydrography data sets, it contains the information about naturally occurring and constructed bodies of water. It has a link to EPA, RC3, river reach flies, and it has a link to GNIS. Is set up for network modeling, and it has three resolutions available, like local scale with no data for Mexico yet, 24,000 complete for New Mexico, and 100,000 for New Mexico. Then the files are being reformatted from coverage to geodatabases. Okay, so these are some specification of this National Hydrography data set, which you can get from USGS. Okay, then DRG. Now DRG is the this DRG is a digital raster graphic. Digital raster graphic. Now, scan of USGS topographical maps is known as DRG, scanned at 250 DIP or greater and resampled back to 250 DIP. Earlier maps maybe are at lower resolutions, so these maps, these DRG, digital raster graphic maps, are very useful for the creation of base maps because they have such a good resolution of 250 GPIs. Okay, so USG digital raster graphic color plates. So digital number values, each color is denoted by different DN values, red, green, and which can be stored into different RGB, red, green, blue band. Okay, so this is the example. Now digital line graphic. Okay, now this can be downloaded from this site. Okay, now here the various layers are there having different feature types. The layers, they include the public land survey system, which is also known as PLSS, the boundaries, the transportation, hydrography, hypsography, non-vegetative areas or features, survey control and markers, then man-made features and vegetative surface. So what different feature classes these layers they include? They include the PLSS, the public land survey system, includes the township, range, and the selection lines. The boundaries, they include state, country, city, and other national and state lands such as forests and parks. Then the transportation, roads and trails, rail networks, pipelines and transmission lines. Hydrography, flowing water, standing water, and the wetlands. Hypsography, they include the contours and supplementary spot elevations. Non-vegetative areas, they include glacial areas, lava, sand, gravel, etc. Then the survey control markers, they include the horizontal and vertical monuments. Man-made features include various cultural features such as buildings not collected from the other categories of the data sets. And then the vegetative surface coverage, which includes the various biomasses, scrubs, orchards, and other things. Okay, so these is done by through different layers having different features. Digital line graph. Then we have the large scale, which includes 7.5 minutes digital line graphs. Okay, so first is the large line graph, which includes the DLG correspond to USGS at a scale of 1 is to 20,000 to 24,000 and 1 is to 25,000 scale topographical quadrant maps. They are primarily cast to the universal Mercator projection transverse UTM, which is also called as UTM projection, but some cast to the state plan coordinating system. Okay, so most of the maps, they are based on the UTM, but some maps, they are also being done as a state plan coordinate system. Okay, they reference to either North American datum, that is the regional datums which you have studied in your GPS theory class, that we have the national and regional datum, national or world datum, ठीक है ना, WGS 84, and we have along with that we have different regional datums also, which different countries they used at their regional level of mappings. So America, for American countries we have NAD, okay, NAD 27, NAD 83. Okay, these files are available in optional spatial data transfer standard SDTS format, and the optional distributed on CD-ROM, etc. Okay, at FTP and the STS formats by FTP download. Okay, so the large scale data having different scales, having different projection system with the regional datum available at NAD 27 and 83 in different FTP or SDTS. Okay, then the individual 1 is to 1 lakh scale DLGs. Okay, intermediate scale. The first one is large scale. The second one is the moderate scale, where we have the 1 is to 10 1 is to 1 lakh scale DLGs, digital line graphs. Okay, now this in class, it includes the individual 1 is to 1 lakh scale DLGs, where where we have sold in 30 by 30 minutes unit that correspond to east and west half of USGS by 30 and 60-minute topographical quadrant maps. Okay, now each 30-minute unit is produced and distributed as 15 by 50 minute cell. They are cast to UTM projection and referenced as NAD 27 or NAD 83. These files are available on optional SDTS or FTP formats. Then we have intermediate scale of 1 is to 1 lakh scale, where the DLGs are derived from USGS 30 by 60 minute quadrants. Okay, and the following products can be available. One is the 1 is to 1 lakh scale hydrography transportation CD, which contains 30 by 60 minute quadrants for the hydrography and transportation layers only. Okay, so the intermediate scale, in which we have 1 is to 10 1 lakh scale hydrography and transportation, in that we get the 30 by 60 minute quadrant of having the information or the layers about the hydrography and the transportation layer. The 14 sectional regional regions of United States covering from 48 states and Hawaii available. So these are the things which we can get through intermediate hydrography and transportation. Then we have the small scale DLGs, which includes the 1 crore 20 lakh scale. Okay, which is derived from the USGS sectional map from the US National Atlas. The products available are 1 is to 1 is to 20 lakh. Okay, state GLG's current data, which is available from SDTs and YE, and then the historical data. Both the data are available as the small scale DLGs. Then we have GNIS, which is available at http gnis.usgs.gov. ठीक है. So in case of GNIS, which is stands for Geographic Names Information System, okay, Geographic Names Information System, where the information developed by USGIS in cooperation with US Board on Geographic Names BGN, contains the information about 2 million physical and cultural geographic features in United States and its territories. Okay, so in this we can Geographic Names Information System, 2 million physical and cultural features information is being stored. The GNIS is nation's first repository of domestic geographic names or information. Okay, as its name is denoting that this is a geographic name information system developed by USGIS in collaboration with US Board of Geographic Names, where they have stored 2 million physical and cultural features of United States and its territory. The GNIS also contains the information about the geographic names of Antarctica, which are approved by the BGN. Information about the foreign geographic features names obtained in GeoNet, okay, name server GNS, and developed by the and maintained by the National Imagery and Managing Agency. Okay, now it is being managed by the National Imagery and Mapping Agencies. Then LULC can also be obtained from the HTTP colon /edc.usgs.gov /products land use land cover /LULC HTML. Now these product, what is this LULC? Okay, as you all know that LULC stands for land use land cover data, which contains the historical land use land cover classification data based primarily on the manual interpretation of 1970s to 1980s aerial photography, and then secondary sources included into the land use land cover surveys, and 21 possible categories of land use land cover along with the LULC file associated with the maps were created. Okay, so 1 is to 1 lakh and 1 is to 2 lakh 50,000. Topographically quadrant it was done for various parts of US, and then in case of Indian context you can also get this LULC through Bhuvan at the scale of list 3, 23.5 meter resolution. Okay, NLCD, that is National Land Cover Data. Okay, in 21 classes that is also being stored. So this is again one type of data which you can get, that is secondary data from USGS. Now US Census Bureau, this is Tiger. Okay, topographically integrated geographic encoding and referencing. Then census book at the level of block, group, and track you can get. Then this Tiger This is stands for topographically integrated geographic encoding and referencing, where where the topographically integrated encoding reference, which is named for the system digital database developed by US Census Bureau to support its mapping needs for the decennial and census and other bureau programming was maintained. Then the census block, group and track. Okay, so a census block, a geographic area bounded by the visible or invisible features shown on a map prepared by US Census Bureau was taken care. In a block group, VG, a statistical subdivision of census tract, is being numbered at different levels, and then it is being stored. Then the census tract, a small relatively permanent statistical subdivision of the country or statistically equivalent entity delineated for data presentation purposes by a local groups of census data or users or the geographic staff of the regional censor in accordance with the US Census Bureau guidelines. Okay, so a small piece of a area is being shown by this census tract. Then NOAA. Okay, this is a data where the shoreline data can be achieved on using this site. Estuarine bathymetry data can be obtained by this site. Then National Climatic Data Center data, where the world's largest active archive of weather data can be achieved through this site. So that is NOAA. Then NCDC, okay, archives 99% of NOAA data, including 320 million paper records of 2.5 million microfiche records. Okay, so this is the data which you can retrieve from NOAA data, 99%. I have told you the site also through which you can archive for that. And then the New Mexico data, with reference to there are some sites. Then the GIS data websites. These are some few websites from where we can get the GIS data. Okay. Then the internet map servers, the image servers, and the feature servers through which you can get different secondary data sets. Then the commercial data, many data products are repacked free data. Then the street map and the address data can be procured. Remote sensing data sets like spot, lidar, US satellite data sets can also be get at commercial level. Ask another US GIS users from where you can get this GIS data sets. So with this, these are some sources of primary and secondary data sets from where you can get different kinds of data sets, where we have studied the primary and secondary. In case of primary, we have tried to cover uh, the different digitizing tools, the text data, and the other surveys data, which we can get through different softwares or hardwares. And then we have also the secondary data sets, where from different websites, from there where different portals we can get different kinds of data sets. So with this, I think I have tried to justify my topic, from where you can get the GIS data sets in terms of its primary and secondary requirement, and what are the categories you need to concentrate, from where you can purchase these data sets, and from where you can freely get these data sets. So I hope I am able to do the justice with the topic. And with this, you all may appear for your quiz through your LMS in your panels. Thank you very much. Good day.